Okay, it is showtime. I want to thank everyone for showing up today for this webinar. I know it's a very popular topic with so many people. It is about asset analytics, native integration with MATLAB. Very popular topic. Today's presenters will be Steve Kwan. He is our PyServer product manager. We've got a couple of people from MathWorks. We're glad to have them along. That will be Tim Choo, the product manager for MATLAB Production Server, along with Sachin Nikumbh, an engineering manager also for MATLAB Production Server. And I am your faithful host, Rick Davin, fellow PyGeek, Senior Technology Enablement Engineer. Along the way, we're hoping for a lot of questions. By all means, there's a place to ask them. If you post them to the Q&A pane, then we'll try to answer them in the order they're presented, or in the ones that interest us the most. But we will try to answer every question posted. With that, I'm going to go ahead and turn the presentation over to Steve.
Okay. Hi, everyone. Good morning, good afternoon, good evening, wherever you may be. My name is Steve Kwan. I'm the product manager for the PyServer. And I want to welcome you to our webinar today. And I want to spend the next couple minutes giving you kind of an overview as to what we're going to talk about in this webinar. So the agenda for this webinar, first we're going to go over some of the goals and objectives of the work that we've done between OSIsoft and MathWorks in terms of integrating our respective products. And then we're going to spend a few minutes going over what a MATLAB Production Server is. That's the key integration point between OSIsoft and MathWorks. Then we're going to have some time to go over some live demos on how everything works and from an end user perspective what you need to do. And in between those demos, we're going to spend a few minutes going over the highlights of AF 2018 with Asset Analytics and all the new features and functions that we're adding to the software. Finally, we'll conclude, and then we'll take questions from the audience. So one of the goals and objectives of this integration that we're doing between OSIsoft and MathWorks. Specifically in AF and Asset Analytics, we have had many customers ask for ways to do more sophisticated calculations. As you know, AF with Asset Analytics do provide to you over 130 native functions, but many of these functions are insufficient for the type of calculations that end users want to do. We have a lot of customers who have a lot of domain expertise that have been codified into MATLAB. A lot of these engineering calculations have been around for a very long time. And my goal from OSIsoft's perspective is to encourage our customers to reuse all this investment that they have put into MATLAB. Of course, we from OSIsoft, we want to encourage our users to get more out of the data that they have in their Pi infrastructure. And lastly, and I want you guys to keep this in mind as we go through the webinar, is that ultimately, we want you, the end user, to be able to execute MATLAB calculations in a streaming fashion. So at a very high level, the integration point between Asset Analytics and MATLAB is via a product from MathWorks called a MATLAB Production Server. For some of you, you may not be familiar with the MATLAB Production Server, so I've asked Tim and Sachin from MathWorks to join us at this webinar. And with that, I'm going to pass the presentation over to Tim, who is going to give you an overview of what MATLAB Production Server is.
All right, thanks, Steve. What I'm going to do over the next couple of minutes or so is to set the stage by taking you through a brief overview of the process to deploy your MATLAB code to MATLAB Production Server, as well as give you an introduction to MATLAB Production Server, tell you what it is. Then I'll hand it over to the main attraction for the day, and the one I think most of you are here for, to see the live demo of the integration between AF and MPS, or MATLAB Production Server. All right, so let's take a look at a typical workflow that you would go through. Usually you'd start out on the far right in your MATLAB desktop. In this phase, you would be developing your algorithm and your code. At this point, you may have imported some amount of historical data in order to do your coding and your testing. And once you're all done, you typically end up with an artifact or your code in a .m file. Those of you who are familiar with MATLAB know that that's simply your MATLAB code. And this MATLAB code has to be run through a product or a utility we have called the Production Server Compiler. Now, the Production Server Compiler is a component that ships with MATLAB Compiler SDK. So this is an add-on product that you have to acquire in addition to the MATLAB desktop. And what it does is that it takes your code, and these M files, these functions that you've written have to be written as a explicit function with inputs and outputs in it. It cannot be just an ad hoc script. Now, as you prepare this for compilation, you may add more than one of these M files. Each of these M files, which contains one function each, is exposed eventually as an API endpoint. So that's what they will become. Now, when you hit the package button, the Production Server Compiler will then package your code into a deployable archive. Now, this is similar for those of you who have come from a Java background, for example, to a .war file or a .jar file. It's conceptually identical. This file has a .ctf extension, the actual sort of acronym of which is not important, but what you do then is you take that CTF archive and you copy it into the auto deploy folder in your MATLAB Production Server instance. And once you do so, it's hot deployed, so you don't have to restart the server. Your code and all these API endpoints are now immediately accessible to all your applications. If you prefer to use a graphical user interface to do so, we have a web dashboard where you can upload the CTF file. But I suspect in many production environments, you prefer to use some sort of automated deployment script in order to copy the file over. Okay, so now that you've copied the file over to MATLAB Production Server, you're probably wondering, okay, what exactly is this? And it's actually really simple. MATLAB Production Server is an application server. It is similar to the Tomcats, the WebSpheres, the WebLogics of the world, except it's not hosting Java code. It is publishing your MATLAB code as APIs that now can be called by your other applications. So we've talked about the first step over in the top over here, where we explain the development process as well as the deployment process, where you package it up and copy it into the MATLAB Production Server in the middle. Now, MATLAB Production Server is very scalable. It can scale both vertically, so as more requests come in, it will spawn additional worker processes to handle them. And if you want to, you can also scale horizontally by adding additional servers and fronting them with a load balancer. So we can handle easily hundreds to, if you scale them horizontally, thousands of concurrent user sessions at the same time. Now, the other key characteristic of MATLAB Production Server is that it is a integration point between your MATLAB code in runtime, as well as a variety of different data sources and different applications. So we'll talk about that in the next slide. So once your code is in MATLAB Production Server, what can you do with it? Well, you can call it. You can call all these APIs, all your functions that you've written with your specific domain expertise, and you can call them from a desktop application or a server application you may have written. This could be a Windows app. It could be a server-based app like a servlet or ASP.NET. And we provide a broad array of language bindings. So we provide client libraries for Java, for .NET, for C and C++, for Python as well. And we also support RESTful API endpoints, and that is straight out of the box. So the minute you copy that CTF file over, there is a RESTful endpoint available for you to call. And what that means is then it opens up access to practically every modern application today is able to make REST calls. So your mobile apps, your web apps, and we use JSON payloads to both send the inputs as well as to receive the response from the server. We also realize a lot of customers want to visualize the results of their calculations in the dashboards. So we have support for most of the popular dashboards out there today, like the Tableaus of the world, the Power BIs, the Clicks, and the Spotfires. Okay, so I mentioned that MATLAB Production Server is, one of its key characteristics is as an integration agent, and that's what this depicts. I mean, we talk to everything from sensors and edge nodes that will, send us telemetry data. We'll be able to integrate with a sort of a compute cluster for additional computing resources if we need to, doing, say, for very computationally intensive calculations. And over at the bottom, you'll see there's a broad array of different data sources that we support. Everything from your relational databases, your NoSQL databases, graph databases, as well as big data, so HDFS, as well as vendor-specific implementations like Hortonworks and Cloudera, as well as big data import formats like Parquet and Avro. And then, of course, who can ignore the whole slew of different cloud data sources that are available today. So we have integration points as well with Azure and its various data sources like Blob, Table API, Cosmos, as well as Amazon Web Services, S3 buckets, RDS, Elastic File System, etc. So it only makes it natural that this is where we would integrate with PyAF. Okay, so I'm going to show you real quickly next what a typical deployment pattern looks like for an organization, for some of our customers who deploy MATLAB Production Server in an environment where we have streaming data coming in. So on the top right, you'll see the development process, which we described earlier, where you wrote your code and you packaged it and put it into Production Server. Now over on the far left, you have your sensors, your devices that are emitting telemetry. They come in through some sort of ingestion engine, like Event Hub or IoT Hub or Kafka. This is pushed to MATLAB Production Server, which usually sits in the cloud somewhere, so in Azure or AWS. And this is where it would run the analytic functions that you have written. Some of that data may be persisted in a storage layer, and then some of it, the results of your analytics functions, are often displayed or surfaced through the front end that the end users interact with. So your custom applications, your mobile apps, your dashboards, etc. So that is what a typical MATLAB Production Server deployment looks like. And with that, I am going to hand it over to Steve, who will take us through an overview of the demo that you'll be seeing for the rest of today.
Well, thank you, Tim. So we're going to move ahead with a live demo, but for the purpose of a live demo, I want to draw a picture in your head, right? So imagine you have an online measurement of data coming into the Pi system, but you know that this online measurement has interesting signals in it, but it's kind of buried in among all the other noise that you may have. So naturally, one of the things that you might want to do is, how do I extract out important features out of this signal that's, it could be noisy, it could be a sum of very many different characteristic signals. So for those of you who may be in this field, one of the things that you might want to do is you might want to do a fast Fourier transform on this signal so you can extract out significant, important, and interesting information from this signal. So keeping that in mind for the basis of our demo, I'm going to pass the presentation over to Sachin, who is going to, I'm going to back up a little bit, who is going to walk through some of the steps that you might need to do to develop a function within the MATLAB Production Server to accomplish the signal processing. So with that, I am going to pass the control over to Sachin. So Sachin, take it away.
Thank you, Steve. Hello, everyone. My name is Sachin, and I'm the development manager for MATLAB Production Server. As Tim has described, deploying a MATLAB function to an MPS instance involves three main steps. You have to write your function, then you have to package it as a CTF archive, and then you need to deploy this archive to an MPS instance. So here is the MATLAB function that receives a signal as a time series data in the form of two inputs. By using discrete Fourier transform feature of base MATLAB, it decomposes the input signal and returns the amplitudes and periods of the component frequencies as the two outputs. The first input of this function contains the amplitude, and the second input contains the timestamp for every value in the first input. Both the inputs are vectors of type double with same length, and both the outputs are also vectors of type double of same length. So the next step is to package this function into a CTF archive. So for that, I'm going to open the production server compiler. I'm going to add the extract signal info file. I'm going to change the default name to something more meaningful, signal analysis. And I'm going to save this project. As you can see, a .prj file representing the project has been saved. Now, MATLAB is a strongly but dynamically typed language. During the packaging process, there is no way to deduce input and output types of your MATLAB function. You can only deduce name of the MATLAB function, how many inputs and outputs it has, and what their names are, but not their types. You need to provide the type information manually using the function signature file. So let's create this file. I'm going to remove the default help that gets generated. As you can see, the signature, this JSON file is already pre-populated with the name of the MATLAB function, the names of the inputs, outputs, and you even have the help extracted from the MATLAB function. So now we are going to update the type information. As I've already mentioned, both the inputs are of type double, and so let's do that. Now the outputs are also vectors of type double, but their dimensions are going to be different than the input. So I'm going to do that. I'm going to save this file, and now I'm going to say package. Now while this is packaging, let's jump on to the third step in deploying the application to a MATLAB Production Server instance. A MATLAB Production Server instance is nothing but a directory with a certain subdirectory structure. The lifetime of an MPS instance can be managed using command line utilities installed with MPS. To create an MPS instance, I'm going to use the utility MPS new, and I'm going to provide a name as a parameter. This name will be used for the MPS instance directory. Let's take a look at what this instance directory looks like. So you will see there is a directory, auto deploy directory. That's where you will be copying your CTF archive. You have a directory for logs, where the logs are stored. And then there is the config directory, where the main configuration file for MPS instance is saved. So I'm going to open the main config file. Now, the main config file, so the main config file is pretty long, but there are two particular configurations that I want to bring to your attention. The --HTTP, this is 9910 is the port that MPS instance will listen on for MATLAB execution requests over HTTP. And the second one at the bottom, the --enable discovery, this configuration exposes a REST endpoint for discovery that allows remote applications like PyServer receive information about the MATLAB applications hosted on this instance. By default, it is disabled, so I'm going to enable this configuration, save the config file, and now I'm going to start the MPS instance. For that, I'm going to use the MPS start utility. Now, at this point, I can use the discovery REST endpoint, and I can ask the MPS instance about the information of the applications. As you can see, we haven't deployed any CTF archive yet, so let's do that. The CTF archive was created in the directory decided by the production server compiler. And I'm going to go to auto deploy directory, and I'm going to copy the CTF. Now, as Tim mentioned, MPS supports hot deployment, so I don't have to restart the MPS instance. If I go back to the browser, at this point, I can get the information using the REST discovery endpoint, information about the name of the CTF archive, what MATLAB functions are included in the archive, what are the types of inputs, what are their names, what are their outputs, and you even have access to the same MATLAB help that you have written in your MATLAB function. So at this point, the extract signal info function in signal analysis CTF gets a unique HTTP URL like this. So hostname, port number, the name of the CTF, and the name of the MATLAB function. Applications like PyServer will be able to send a post request to this URL where the request payload will contain the inputs to the MATLAB function, and you will get the MATLAB results in the response. And Steve will demonstrate how this can be done from PyServer in a few minutes. So I'm going to hand it over to Steve. Here you go, Steve.
Works better if I unmute myself. So thank you, Sachin. So for those of you who are watching this webinar, what you've seen so far is Sachin having written relatively simple few lines of code in MATLAB. And the important things to remember is that he compiled it and deployed it with the MPS server. So if you can imagine, if you have a lot of engineers or whatever, they can all be writing their own MATLAB code, they could all be deploying it, and everything will be hot deployed without the need to restart any services. So with that, I'm going to move forward and spend a few minutes giving you some highlights of what we're doing with AF 2018, Asset Analytics, and how and all the things that we are doing to support this integration with MATLAB and Production Server. So in AF 2018, which is tentatively estimated to be available in June of this year, our focus is going to expand the PyData infrastructure for you to be able to do more with your data. We're adding support for arrays and analytics, primarily so that we can support the integration with MATLAB and MATLAB Production Server. With the introduction of support for arrays and analytics, we've added new functions which are focused on arrays. And in addition, we're enhancing existing analytics functions so that they become more aware of arrays rather than individual values. And lastly, we built the framework to allow AF and analytics to connect to external systems, keeping in mind that further on down the road, we're going to explore integration with other external systems. So here's an example of some of the new capabilities that we have added to AF 2018. So basic array handling. As you know, if you're a longtime AF user, the support for arrays in AF has been lacking in the past, and we're slowly improving on that. Now, when you have arrays, one of the first things you need to do is to be able to populate an array. So we're adding new functions, or we have added new functions that are based very much on the AF SDK that would allow you to retrieve data from your PyData archive and populate arrays within AF so that you can further work with this data, including passing this data over to the MATLAB Production Server. So here's a screenshot of some of the new functions that we're adding. For example, if you look at the first row, that's a new function that would allow you to retrieve interpolated values from an attribute with a time step. In this particular case, you're looking at the last hour and 30-second time steps, interpolated values. From an array management perspective, you can, for example, get the length of the array, you can get the first or last value of the array, and you can work with individual values within the array. So I want to draw your attention to the line that says variable 3. This is a new function which complements interpolated values, which is to bring back the recorded values from a particular attribute and populating an array with these values. Some more examples of array management. So as an example, previously the average function really only worked on individual values, but we have enhanced these functions to support arrays. So if you look at variable 6, you're looking at the average of the adjusted array, which is the row above it, which has multiple values. So the average in this particular case will give you back the average of every value within the array. I want to draw your attention to variable 3. You notice that we're adding a new function called filter data, which will allow you to take an array of values and filter that array into values that you need in order for you to pass on to the MATLAB Production Server. Similarly, adding a new function called map data, which would allow you to basically apply logic to every value within an array. So if you can imagine the data handling and the data management that you can do with multiple values in an array have been greatly enhanced with the upcoming 2018 release. So with that in mind, I'm going to switch over to demo mode and give you an idea on what the new PySystem Explorer, how it works, and also some of the new capabilities and how it integrates with what we've done with the MATLAB Production Server. So here's PySystem Explorer, and I just have a demo database here of pumps in a pump station. And I'm going to go over to, say, pump number 1, and you notice that I have a bunch of attributes here. And before I move on, I'm going to show you a new capability to connect to external systems. So specifically, I'm connecting to a MATLAB Production Server on localhost on a particular port, and I can test the connection. And because of the discovery feature in MATLAB Production Server, I know what are the MATLAB CTF files that's been deployed on a particular MATLAB Production Server. I'm going to save this, and I'm going to go look at the analysis pane for this particular pump, and you'll notice that we now have a category of functions called MATLAB. And within this category are all the CTFs that's been deployed on the MATLAB Production Server. And we will dynamically update this list as people add or remove functions into the auto-deploy folder for MATLAB Production Server. I want to draw your attention to the bottom of this screen. You notice that we provide as much information as possible based on the information that you put into the MATLAB function that Sachin demonstrated earlier to you. So we know that this particular function takes two inputs. The first one is an array of values. The second input is an array of timestamps. And we also show the help information that's available from within the deploy CTF files. So if you can imagine, your engineers can be writing MATLAB functions with sufficient information so that the next person, the user, would be able to utilize these functions without having to track the person down to understand what those functions do. So I created a new analysis here called MPS signal processing. And what this particular analysis does is I'm going to bring in the interpolated values over the last 24 hours in 1 second increment from an attribute called demo mix signal. Next row, I'm trying to find out how many values there are. And then I want to grab the timestamps of every single one of these values from this particular signal. And then I'm going to send the values and the timestamps into the MATLAB function, as you can see, extract the signal over here. And then the output, I'm going to get back two arrays. One of them is the amplitude, and the other one is the periodicity of the interesting signals within this particular demo mix signal. So I'm going to go ahead and evaluate. And the first time through, it's going to load everything, and it should hit the MATLAB Production Server, and it'll come back with a bunch of results. So let's look at these results a little bit more carefully. You notice that the first interpolated values call brought back 86,000 values. And then when I grabbed the timestamps of these values, it gave me another array of 86,000 values. And then I pass both of these arrays, which is 172,000 values, into the MATLAB Production Server. And the MATLAB Production Server gave me back two arrays. So as you can see, the first array contains 3 values, which are the amplitudes. And the second array returns 3 values, which are the periodicity of the interesting signals within this measurement. Now, I can grab the first value from the first array, and I can save it as an output to a PyPoint. So what does that mean? That means I can do things like evaluate it. I can also, if I start this up, it's going to take a few seconds to start up because we're trying to sort things through in the background. And we can do things like, I can go ahead and do before I do that, I'm going to run this, I'm going to set the scheduling for this particular analysis to be every 10 minutes, just like that. Then I can do things like, I can do a preview since midnight last night, and it will generate the results just like what you would expect from using any other functions within AF and Asset Analytics. Everything works exactly the same as you would imagine Everything works just like any other function that you have. So you can do things like evaluate it, you can do a preview, you can do backfilling, you can do recalculation. All that is supported. From your end user perspective, it's just like any other functions within AF. Okay, so now, just to demonstrate, you know that the MATLAB function returned an array of 3 values of periods 12, 6, and 4. And if you go back and you look at how this particular signal was generated, this particular signal was generated from 3 sine curves of 12-hour sine wave, 6-hour sine wave, and 4-hour sine wave. And for the purpose of the demonstration, I added these 3 sine waves together along with a fractal value to give me a mixed signal that I use as an input to my demo. So that's a quick demonstration of how everything works, and I am going to go back to the slide deck. So in conclusion, we think that Asset Analytics integration with MATLAB and MATLAB Production Server can solve new problems for you that you may not have been able to solve before using AF and Asset Analytics prior to the 2018 release. Everything works just like it did before. The beauty here is that an engineer can create MATLAB functions, drop them into the auto-deploy folder, and we on the AF side will pick it up automatically and utilize these functions just like any other function. Because we're using these MATLAB functions just like any other functions within AF, you are able to schedule your analyses and run them in a streaming fashion just like what you've been doing before. I do want to point out one thing though. In this integration scenario that MathWorks and OSIsoft have been working on probably in the last 9 months that we've been working on this, it is clear to us that from an end user perspective, the user ought to use the correct tool to solve your particular problem. So as you saw, these MATLAB functions, once deployed on the MPS, and the way we integrate it with AF, really helps us execute these MATLAB functions in a streaming fashion. Okay, so these analyses are running online, they're scheduled, and these calculations are being done in a streaming fashion. However, if you're an engineer and you're trying to create, you're trying to investigate, you're researching, you're trying to find a mathematical solution to your problem, you wouldn't do that necessarily from within AF, but rather you would use some other native tools that supports ad hoc type of batch type investigation. So in this particular case, you would probably want to use the native MATLAB client tools to build these functions, to do your investigation, grab some data from the Pi system, build up your logic, build up your script. But once you're happy with it, all you need to do is compile it, drop it into the auto-deploy folder, and you can pick it up in AF and run with it in a streaming fashion, just like that. Here are some additional resources on the MATLAB and MPS side. So there's a product page for the MATLAB Production Server, user stories, various webinars that you can download, and you can also request a trial license for your MPS server. The contacts for this particular webinar and anything related to the MATLAB Production Server is Sachin and Tim. And again, Sachin is the engineering manager, and Tim is the product manager for the MATLAB Production Server. With that, I'm going to pass it back to Rick.
Rick already
away,
took control. All right.
All right.
As a quick reminder, in case you've been under a rock, you don't know, we have PyWorld coming up next month on April 23rd through the 27th. Would like to say there's the Innovation Hackathon on day 0. That'll be Monday. Hope to see everyone there. Come by and see us at the Pi Developers Club booth. Also on this related topic about Asset Analytics and MATLAB, there are going to be 2 presentations on day 3. That's Thursday. So the first one's at the Hilton in the morning. And I know we're talking about having another one earlier that day. And the second one is in the afternoon at Park 55 Hotel across the street. Steve will be in both of those. You can bend his ear. I do want to recommend you probably want to go to the one in the morning, but in the afternoon you actually want to come to mine, where I'm going to be giving a talk on AF Search alongside David Hearn. So sorry to steal your thunder there, Steve, but anyway, we're now open to some Q&A. I know we've got a lot of questions already in the hopper, so panelists, if you unmute your mics, and we will cover them. The first question is, what happens if MATLAB Production Server can't keep up with the requests coming in?
This is Tim. All the requests will go into a request queue, and they will be routed to the next available worker once it frees up.
Okay. Same person had another follow-up. So will Asset Analytics also fall behind?
So, good question. So a couple of things that we're doing on our side is we are working on providing metrics on what the expected round trip and calculation cycle is going to take. So that from an end user perspective, you have an understanding as to how intensive your calculations are and the time that it takes for your calculation to complete. We are working on some new capabilities in the 2018 release to try to minimize slowdowns based on dependencies and so on. But at the end of the day, if you're triggering faster than what your execution cycle is, we're going to fall behind. So, for example, if your execution cycle takes half a second, but you're firing your calculations every 250 milliseconds, we just can't keep up. Therefore, we will fall behind also.
Okay. New question is, does the MATLAB Production Server allow graphic I/O like G input from the UI to the back end?
I am not familiar with what G input is, but Sachin, would you like to take that, or Steve?
So I'll just answer that question at a high level. MATLAB Production Server is an application server for MATLAB functions only. It doesn't support any UI capabilities. If you need UI support, as you have seen in Tim's presentation, you'll have to use products like ClickView, Tableau, Spotfire, and then you can use our REST interface to send execution requests to MATLAB through MPS.
Thank you, guys. Next question, is the production server available as a Docker container?
Not from an out-of-the-box supported perspective, but we do have recipes that will walk you through the process of packaging it up as a Docker container. Bear in mind, it's a fairly hefty Docker container at several gigabytes. And you might need a little bit of assistance. We have engineers who might be able to help you walk you through this process. But yes, we've done this.
Okay, good. We have another one. How many MATLAB production servers should we acquire? just one, or 24? Thank you.
So one MATLAB Production Server license gives you the ability to use up to 24 worker processes. So you buy the one license and you have the capacity to handle, one worker process handles one request at any specific point in time. It's a stateless call, so typically it executes in, less than a second, or it depends on how compute intensive your function is, and then it is freed up for the next available task. So this really totally depends on how many concurrent requests you expect to receive, as well as what is the latency for each of your function calls that you are expecting. With that two major pieces of information, we'll be better able to help you decide on the sizing that you require, whether you need more than 24 or not.
And I just want to add to what Tim has mentioned just now. In my demonstration, I showed that I created an MPS instance, which is a directory, and that's bound to that port 9910. But on the same machine, you can create multiple such MPS instances and start them. And as long as they are all using a unique port, you can have multiple MPS instances running on the same machine as well. And you can deploy either one CTF or more than one to one MPS instance, or you can deploy multiple CTFs across multiple MPS instances.
Okay. This one might be for Steve. Are there any functions to store the array back into tags? And then I have a ... and array data reference for an attribute.
That is something that we're working on. I'll go beat up the developers to make sure that they work a little faster, and maybe we'll actually feed them. But all joking aside, so in AF we have an array data type for an attribute. We also have PyPoint array data references. Our goal is to allow users to take the output from the MATLAB calculations and populate both of these scenarios, attribute arrays and also PyPoint array data references. It's the work that we're working on now, and as quickly as we can, we will make that available to our users.
Okay. With load testing of this, are there any issues you have seen with large data sets? And the questioner said, I like the 1 day, 1 second demo there. Just curious what kind of array limitations there might be.
Is this for the OSI side or on the MPS side?
I would think both, especially since they mention arrays.
Okay. So we have no built-in limits, but I'm sure we'll run into like operating system limits and so on the AF side. So as you saw in the demo, we passed in 2 arrays of 86,000 values each. So that's a pretty good size array. As we continue on our development, we're going to do scale testing. We're going to place a lot of importance on that. We will know as we get closer to release if there are any practical limits.
So on the MPS side, the demonstration that you saw from Steve, it used the REST interface that MPS has from PyServer, and it uses JSON as a serialization format. So your payload size will increase as you send more and more data. But there is no technical limitation from MPS side either for how big of a data set you're sending.
Okay. We have 2 questions from Aaron. One, is there going to be support for roll-up analytics? And the second is, can entire arrays be written to an output or just single values?
Okay, so I'll touch on the first one first. Currently, there is no support for roll-up analyses. Currently we don't feel that it is a very high value feature, and there's complexities associated with enabling that. So perhaps you can create an item on user voice and kind of talk to us about some of your needs. Secondly, as to writing the array to an output, we touched on that earlier. Right now is single values. Over time, we're going to let you write the outputs to PyPoint array data references.
Okay. We have a little over 6 minutes left, and we have a ton of questions. So if we are not able to get to your question, we will get it in writing and post it later on PySquare. So moving right along, what method do you recommend for importing data to MATLAB from Py?
There are. Oh, Steve.
No, go ahead.
There are a few methods. I think if you have the data access server, is that what you call? You can use ODBC or JDBC drivers that we provide with a database toolbox. We also have an OPC toolbox if you have that OPC server available to import the data. Steve, did you have anything to add?
No, you got it all correct. So just to expand on that a little bit, if you have just raw PyPoints and you don't really have an AF structure in place, you could use OPC, but I think based on the attendees in this particular webinar, I suspect that you are relying on AF, in which case my recommendation would be ODBC, OLEDB, or JDBC. Any one of those technologies, you'll be able to grab data from your Pi system and bring it into the MATLAB IDE.
All right. Next one is how much data can be loaded between the Pi system and MPS? For instance, can we load hundreds of megabytes?
I think Sachin addressed that in the question just before this.
Okay.
Do you want to repeat that, Sachin?
Technically, you can. But again, as I said, because we are using REST API, which has the JSON payload, the more data you send, the JSON is a verbose serialization format. And we also have a binary serialization format, which is not currently supported with Pi server, but we will be working with Steve's team to add support for that in future.
Okay.
Yeah, so just one comment on this. Okay. Recall what I said earlier in the conclusion slide, right? You have different usage scenarios. It is unlikely, at least in my mind, that you would ever send hundreds of megabytes of data in a streaming fashion, running your analyses on a schedule, right? I'm sure there are edge cases, but I'm trying to understand what the needs are from a streaming fashion. But technically it's possible, but I think what you're going to find is that sending that much data across the wire in JSON format with a huge payload, from a performance perspective, it would be impactful.
Right. Don't expect a half-second calculation time.
Yeah.
All right. This was for Steve. Do you plan to integrate AF with R as well? What about Python, and is there any roadmap?
Well, we built our integration framework as generically as possible. So in theory, it is. A lot of what we want to do will be based on customer demands. So technically it's possible, but we'll let customer demands drive what we do from a roadmap perspective.
All right. This would be for MathWorks guys. How is MATLAB licensed, and can MPS be very small and cheap or even free for dev purposes?
So you have a few licenses at play here. You need one license for the MATLAB desktop. You also need licenses for the MATLAB compiler and compiler SDK in order to generate the CTF archive from your code. So this is separate. MPS is licensed separately. That's a server product, while the earlier ones are license on an individual desktop level. So MPS, the MATLAB Production Server, is a server-based license. You buy one license and you get 24 workers of capacity. This is licensed both as a perpetual license, or you can buy an annual term license as well. With regards to whether it can be cheap or free for dev purposes, if you have the MATLAB desktop and the compiler and compiler SDK on your desktop, as a developer, the compiler SDK supports a feature called dev and test. So during the process of compiling to your CTF archive, you can run a dev and test environment. If you're a Java developer and using Eclipse, it's similar to running like a little local server so that you can test your function against a single worker MPS instance running on your development workstation. So that allows you to do development testing. This does not, however, work. That single worker dev and test environment, however, does not work with your AF integration. If you want to do the AF integration, you have to buy a full MPS license for that.
Okay. And as I said earlier, this is a very popular topic, so we have tons of questions that we're not going to have time to get to. That means this is going to be our last question on audio, and we'll address the other questions in writing when we post the recording back to Pi Developers Club. Meanwhile, if you still have questions, by all means type them in. Like I said, we'll try to get to them. So last question, after deployment of the CTF to MPS, is it possible for Pi to record a checksum or version info from the deployed CTF? So for instance, in biotech, pharma, manufacturing environment, where he needs to know with certainty what version of the MATLAB function was used to calculate the result for the timestamp.
We currently do not have that capability on the OSI soft side, so that's certainly something that we can work with the MATLAB from the MathWorks folks to see what we can do. Thank you for the suggestion.
Okay. And again, we will address the, go ahead.
Rick, before you sign off, maybe Sachin can touch on what the CTFs look like from a security perspective. My understanding that it is.
Yeah, so as far as security goes, the MATLAB code is encrypted to preserve your IP. That's the main reason why we do the encryption. The other feature MPS supports that Pi server is currently not supporting is communication over HTTPS. So your data is protected. And as far as versioning goes, the CTF, since the name of the CTF is exposed in the URL, currently the versioning unfortunately needs to be reflected in the CTF name. So if you have version 1 of you have multiple versions of the same CTF, you will have to come up with some naming convention on these different CTFs.
Okay. So just one more thing, Rick. When we release this with the 2018 release, we will support HTTPS. It's
okay.
That's just something that we expect to be able to do when we ship this in June. That's it.
All right. So that concludes this. I'm going to go ahead and leave the event open for a few more minutes if anyone wants to type questions. And again, we will address the questions in writing at Pi Club. Thank you for joining us, everyone, and please drive safe.